Okay, in this video I'm going to go through quadratic graphs, in particular sketching quadratic graphs. Okay, so we'll start off by sketching a simple graph. So let's say we have y equals to x squared plus 2x minus 15. Okay, and they'll say sketch this. So let's say if they ask me to sketch this, this is what you do. Okay, so there are a few key steps here. The examiner will be looking for your calculation of intersections with the axis, so where the graph crosses the x-axis and the y-axis. You need to show these calculations. It's not just sketching a graph. You got to show you know how to sketch a graph using the correct method. Okay, so this is where a lot of people lose marks in the exam, because they just sketch things just mentally. Even though it's the right sketch, you might not get the full credit because you haven't really shown your working out. So first thing you do, I just want to work out where this graph is crossing the x-axis or y-axis, let's say. So let's say when x equal to 0, so you can clearly see if x is equal to 0, that's going to be 0, that's going to be 0, so you end up with just minus 15. So y is equal to minus 15. So that means this graph goes through 0, minus 15, because when x equal to 0, y is equal to minus 15. Now if you want to work out the x-intercept, it knows a little bit more work, because when y equal to 0, so if y is 0, all that is equal to 0. So that means x squared plus 2x minus 15 equal to 0. So what we have here is a quadratic equation. You can clearly see this is factorizable. If you factorize it, it will be x plus 5, x minus 3 equal to 0. Okay? So that means x plus 5 equal to 0, or x minus 3 equal to 0. So that means x equals to minus 5, or x equals to 3. So we have two places for the x-intercept. So it's crossing the x-axis at minus 5, 0 and at 3, 0. So we have two intersections. So that's half of your solutions. So as you can see, there's nothing here to show that there's a sketch here. So we need to sketch the graph now. So what I do, I draw my y-axis and x-axis and label them x and y. Always label them. Okay, a lot of people forget these things, but it's very important that you do your graph correct. Okay, and then mark your point. So 0 minus 15 is 1 point. So let's say somewhere here 0 minus 15. Okay, and then you have a point 3, 0. So let's say somewhere here 3, 0. Now watch how I actually write down. I do a little cross and then write the point there. A little cross, write the point there. And the next point is minus 5, 0. Minus 5, 0. So just make sure this here is slightly longer than this, because 5 is technically slightly longer than minus 3. Now there's a y-intercept here, so the graph is going to go something like that. Now before you draw it, just take a moment and see where this graph is going to turn. So if this is 3 and if this is 5, the midpoint is about here, minus 1 roughly. So it's going to turn after going down from here, somewhere down here. Okay, so it's very important. Not every graph is going to turn right in the middle, because this side is longer than this side. So it's going to go like this, and then turn about there, and then come back like that. So there's my graph. So that's how you sketch a quadratic graph. Okay, now if you want to copy this down, you can pause the video and just copy it down, because I'm going to rub this off. Now what I want to do is I want to actually go through what kind of a graph we can expect by looking at the actual equation itself. Because from the numbers in the equations and the signs of the numbers, we can roughly figure out which way the graph is going. You can't get the exact graph, but you can kind of guess at least what shape it is, whether it's going, whether it's a positive graph, a negative graph, or in terms of just casual words, whether it's a smiley or a sad face. Okay, because a quadratic graph can either be something like that or something like that. Okay, now whether that or that depends on the graph. So any quadratic graph is going to have this form: y equals ax squared plus bx plus c. Okay, so this is similar to quadratic equations. We start off with this expression there. So if it's going to be in this shape, then the a has to be greater than 0. So the value of a has to be greater than 0. That has to be a positive number. So if it's x squared, it's positive 1. If it's minus x squared, it's minus 1. If it's 2x squared, it's positive 2. If it's going to be in this shape, then it's going to be a less than 0. Okay? Now, there are a few other things that we can look at. So is that clear? I'm going to rub this off. Okay? So that's the first thing. So that first number, more importantly the sign of that number, decides whether it's a smiley or a sad face. Now let's see what else we can figure out. Now there's something called the discriminant. Okay, discriminant. Okay, the discriminant is b squared minus 4ac. So if the discriminant is the bit, so if I write the quadratic equation here, is minus b plus or minus square root of b squared minus 4ac over 2a. So that's your quadratic equation. So discriminant is the bit under the square root sign. And you can clearly see, now this has to be 0 or positive in order to get an answer from quadratic equation. So if that's negative, you can't get an answer. So that means if that's negative, we don't have any roots. So if b squared minus 4ac is negative, which is less than 0, then we have no roots. No roots meaning this graph, this particular graph, if it's a, well, it's not this particular graph, but I mean in a graph where b squared minus 4ac is less than 0, i.e. negative, that graph does not cross the x-axis at all. So it could be something like this. It could be either like this or like that. So you can see in both cases the graph does not cross the x-axis. So it could be something like that. So that's the first type of a graph you can get using the discriminant. Now the next possibility is if b squared minus 4ac is exactly 0 or equal to 0. So now if that bit's equal to 0, then we're going to get only one answer for x, isn't it? So that means we have one root exactly, or in other words we can say equal roots. So if you factorize an expression, you're going to get the same bracket. So this is the example where the graph exactly touches on the x-axis, or it bounces off the x-axis. It can happen from down below as well, like that. Okay, it can happen on that side or that side, so it can happen like that as well, or like that. Okay, or it can go right on the 0 as well. Okay, so it can be any one of these potential scenarios. Now the third type is when b squared minus 4ac is greater than 0, then we have two real roots. Okay, real roots meaning we're getting two different solutions. Okay, so is that clear? So it's something like basically the graph we drew, so something like that or something like that. Okay, I know you can't see that diagram, so what I drew is something like that. Okay, so you can clearly see there are two locations where the graph crosses. So I hope that's clear. I'll do an example very quickly. Okay, let me just rub this off. Okay, you don't need a really big understanding of this, but a general understanding would help you in the long run. Okay, I mean you can just about brush past first year's A-level maths without knowing things to details, but you're really going to be found out in the second year if you don't learn them properly. So even though your exams are very easy, the C1 and C2, it's better to learn them properly, because if you don't learn them properly, if you just about get an A star or an A just by revising just for the exam, you might not actually learn properly, so you're going to have a problem in the second year. And that's usually the case. If you don't learn properly, you're going to have a problem in the second half of the course, not in the first half. Okay. Now, let's say we have a question. So let's say we have kx squared plus 2k minus 1 equal to 0. Okay? So they're going to ask us a question like this. They're going to say, find possible values of k for which the equation has equal roots. Okay, so what that means is they want you to work out the possible values of k so that this equation has equal roots. Okay, so what we have to do is, so if it has equal roots, so that means b squared minus 4ac equal to 0. Correct? Because you know that's the only way you're going to get one root or equal roots. So in our equation, well, let's start with a. So a equals k, b equals 2, c equals minus 1. So b squared minus 4ac, so b squared will be 2 squared, 4 bracket a is k and c is minus 1 equal to 0. So that means minus 4 times k times minus 1 is plus 4k equal to 0. So 4k equals to minus 4, so k equals to minus 1. So when k equals to minus 1, this equation is going to have equal roots. So I hope that makes sense. Okay, so all you do is whatever the information they tell you. So if they tell you this has 2 roots, then you just do that greater than 0. If it says it has no roots, you do less than 0. Because it says it has equal roots, so all you do, you make b squared minus 4ac equal to 0. Just write your lineup of a, b, c here. A equals k, b equals 2, c equals minus 1 in this particular question. Fill them in and work out the value of k. It's very simple. Now, in the next video, I'm going to do quadratic inequalities. Okay, I'm not going to do normal inequalities. I think you should have done them in GCSE level. So I'm trying to do videos for topics which are slightly beyond GCSE level. So you know, you need to have a grade A or grade A star in GCSE to do A levels. Maybe with a B, but then you're going to have to do a lot of hard work to get there. So I'm going to leave it there. So we'll go through inequalities next video, and then I can do similar questions where b squared minus 4ac is greater than or less than equal to 0, because we need to know inequalities in order to do that. Okay then, I'll leave it there.